Hello, dear students. In this video, we are going to talk about how we can make and express our decisions about the structural system of the building. First, we are going to examine the design process and its four main steps. And then we are going to check the decision-making process and how we can express them. Uh, and let's start with how do we design? Um, as you know, designing means making lots of decisions. And if we want to have a functional and aesthetical building, then that means that we need to make appropriate decisions. And since there are lots of things to be decided, like the form of the building mass or masses, or spaces, their positions, their locations, their directions, and how they are going to be related to each other. Uh, Lots of decisions, uh, it'll be maybe easier for us to make these decisions in an order, step by step. And of course, at the beginning, we need something to step on. We need some sort of base to make all these decisions. And that's where the three C's, context, concept, and content comes into play. Context, as you know, the surroundings, the environment. If this is our design area, then it will be surrounded with this existing environment, which can have either natural environment properties like the sun rays, air properties, precipitation, or it can have a built environment uh, like other buildings, like roads, and everything that has been created by man. And of course, if there are people living in this neighborhood, then we can talk about the social environment. So uh, we can start with the analysis of context. And if we understand what's going on there, then that will guide us throughout our designing process. The other important thing is the content, everything that will be included in this area, especially the user. Again, we can make an analysis, we can examine the properties of the user, and that will again guide us throughout our decision-making process. And if we can come up with an idea, a concept, that's the underlying idea, we can use that idea to make better decisions. It's something like this. We are first trying to understand what are the main properties in that area and what are the main properties of the content, the user, their activities, and by examining them thoroughly and looking their past conditions, their current conditions, and trying to imagine their future possible conditions, we can we can start to relate them, connect them to each other, find different connections. And when I say connections, of course, I'm talking about effects, causes, and results. And based on these network of effects, connections, we can make proper decisions in order to relate certain things together. And all these connections, all these relationships, they depend on our approach. If we change our approach, if we change the underlying idea, the concept, then of course, we can figure out different connections, different relationships, and make different decisions. Uh, so that's the that can be the basic definition of the architectural design process. And what are these hierarchical steps? Um, Generally, it's four main stages. Of course, there can be different approaches, but this is something that we can start with. Uh, since there are lots of things to make decisions about, and we need time. If you imagine that that's a timeline, we can start with the pre-design. Pre-design, in Turkish, we call it analiz. That's where we are looking in detail about the existing context and the properties of the content, the user, try to understand their different aspects, so that we can make relationships, find connections, and have this underlying idea, and everything will be every other step, the other steps of the design process can step on these base. We can use our findings as a proper base, and we can. After that, we can move on to the schematic design. In Turkish, we call it avant-projet. That's a French word, and the Turkish translation is ön tasar. Uh, and in the United States, they are calling it the schematic design. And in this stage, we are mostly making decisions about the building, the form, the location, the masses, their positions, their directions. And we can, at this stage, we mostly make sketches, try to figure out what will be the possible positions and sizes and uh, geometrical forms of the building or building masses, and how are they going to be related with the existing context? How are they be positioned? And how do they look like? What the building will look like? Um, we can have different techniques. We can do 2D sketches, 3D sketches, 3D models, uh, and make uh, try to develop our decisions about the appearance, the facade, and of course, especially the units. You remember this example, this ecological living module designed by Gray Organji Architecture, and here the decisions about the building mass, we can see it right in front of us. It has this geometrical shape, and it has some surfaces have this color with strips on the vegetation. The upper part has different visual aspects. Some parts are transparent, and so on. And after our decisions, or based on our mass decisions, the form decisions, we can move on to the units. These will be the living areas that we are going to provide for the user so that they can have their life and do certain functions. And again, there can be different techniques that we can use. We can create bubble diagrams in 2D or 3D form and try to locate each one of the units in this mass. These can be open air units, closed units, semi-closed units, and there can be different connections between the units. And in each living area, we can try to figure out the space properties, like the light or the ambience or the air, and how they are going to be related to each other. Once we develop and improve our ideas, uh, by that I'm trying to say that we need to imagine what kind of living environment we are going to provide for the user. Uh, we need to express all of our decisions to mostly the user, so that they can understand what we are thinking. And in this for this expression, we can use plans and sections. Plan is the horizontal section of the building, and this is the vertical section, obviously. And anyone who looks at those drawings, they can easily understand the living areas, the living spaces, and the final visual aspects of the building. Uh, the users, they don't need to be educated in terms of technical drawing. However, these drawings generally we create them 1/100 scale, and of course we can do renders, we can do models. However, mostly we prefer plans and sections and elevations in 2D form, and we use colors. That's why we prefer them, so that anyone who looks at these drawings can easily understand the living arrangement and the properties of the spaces, and especially what the building will look like when it's finished. Uh, so those techniques are for the user so that they can easily understand our ideas. And if there's something that they didn't like, they want to change it, they didn't find appropriate, then we can work on that. They can give us feedback and we can improve our or develop our design. But once we agree on the building decisions and the unit decisions, we need to move on to another stage. This time, we need to make decisions about the construction phase. And yeah, we need to think about how we can create all these solid building form and the volumes, the spaces, living spaces, with what kind of elements. As you remember, building elements are specifically created in order to execute one or some of the functions of the building, like protection. The building needs to protect the user from all the negative features of the context, and the building needs to provide certain functions like preparing food or sleeping or resting to the user. And all these functions that are created, they are managed by the building elements according to our decisions. What kind of walls, what kind of a roof or building structure, stairs are we going to design? And all of these decisions about the stairs, about the floors, and about the roof, they can be based on our previous decisions about the building mass and units. We need to figure out what kind of a roof we need to design so that the building will look like this, and so that the building will provide protection, necessary protection for the user. Like this staircase. There can be many different alternatives for the staircase with different shapes and colors and geometrical forms. Uh, However, these architects, they designed a staircase like that so that it will provide the necessary function and it will be appropriate with their previous unit and building decisions. Uh, and as you remember, each one of these building elements, uh, they are made out of components. So once we make decisions about the building elements, we need to move on to think about the appropriate components. Uh, and here we talk about building structure, that's an element. However, each one of these elements, like this wall or this roof, they can have their own structure as one of its components, one of their components. Like this wall structure, it's the middle part or main body of the wall. Like this roof structure, it's the middle or body part of the roof. And we can think about finishes and isolations. And we need to figure out what kind of pieces we need in order to create these components. And out of what kind of materials we can create all these pieces. That's what we are deciding during the construction stage. So, people, this time we are face to face with not the user, but the engineers and the builders, especially. They are going to provide all these pieces and components, and they are going to assemble them so that all these units and building itself will be constructed in the real world. And here we need to make expressions for the builders and engineers this time, and they have their technical information. They know how to understand the technical issues. They have been educated there, and now we can use 1/50 scale, and obviously our expression style it change because we are not face to face with anyone now. There are educated people and when I say educated, they can understand all these technical issues. So we don't need colors anymore. However, we need different things like these texts. These are the explanations for our imagination, for our decisions about the building products. And there are numbers. These are the sizes, required sizes, our decisions. So these drawings are some sort of instruction for the builders to create the building in the physical environment, physical world. And if it's not enough, we can zoom in, so to say, give more details, especially for the connections of different components or pieces. With those information, with those detailed information, builders can first get the materials and they can shape them into pieces and they can provide the required quantity and then they can start to connect them uh, as our imagination according to our decisions. Something like this. It's our way of telling them what to do and how to do that. Of course, we can create different types of documents, but mostly, again, we use plans and sections so that they can understand the connections. And this time, the scale, it changes. We can either do 1 over 20, 1 over 5, or 1 over 2. Something like this. Here, this drawing is 1 over 20, and it looks detailed enough. However, it's not. We need to sometimes enlarge certain areas, points, zoom in to these points and give more information so that they can create the objects as we like, as we imagined, and they will function as we decided. Uh, so this is the general thing, the four steps. And in this course, hopefully, you are going to especially learn how to make construction design decisions, detailed design decisions, and how to express them. Uh, so let's start with the decision making. How can we make proper decisions for the building structure, for the element, the building structure? Let's take a look at them. Uh, if we want to create a stable, a strong building structure, first of all, we need to make the decision about the load transfer, how the loads will be met and carried and transferred. Uh, you remember from our last video, this is masonry. All the wall surfaces, all the vertical surfaces, they do the carrying. They meet the loads and they transfer them safely to the ground. If we want, of course, we can do a masonry structure, or if you want, if it's required, we can decide about a skeletal structure, and that can all these decisions can be made according to our previous decisions about the building form, about the context, like the ground properties, like the earthquake risk, all the possible loads that can affect the building and we can have, of course, structural engineer opinions and make the final decision. Let's imagine we make the skeletal, we decided that the structure will be a skeletal system. Then obviously we need to concentrate on the vertical components. Are there going to be columns? Or shear walls or both of them, and what will their sizes be, and how many of them there will be, and what about the horizontal components like the beams? Again, how big of a beam are we talking about, and how many beams, and how are these vertical and horizontal components be connected to each other, where they will be located, and most importantly, out of which material we are going to create them. We can use, as we learned last time, we can use concrete and we can have steel and cast them into these steel reinforcement bars. And when we combine concrete and steel together, we can have reinforced concrete as the material. And we can create all these vertical and horizontal components out of reinforced concrete. Of course, the structural engineer, they need to do the calculation so that we can finalize our decisions about the sizes. However, there are regulations that we need to always keep in mind, which says that if we are going to create a reinforced concrete column, it cannot be smaller than 25 to 30 centimeters in plan. If this is 25 centimeters, then that needs to be 30 centimeters. If this is 30 centimeters, of course, the other side needs to be at least 25 centimeters. It cannot be smaller than that. And if you need a shear wall, then again, the thickness cannot be smaller than 20 centimeters. However, it needs to be proportional with the total height of the uh, shear wall. We need this total height and we need to divide it by 20 in order to find the required thickness. And the beam, a reinforced concrete beam cannot be thinner than that size, cannot be smaller than 25 centimeters, and the height, that size, cannot be smaller than 30 centimeters. However, it's not enough. Again, we need to first figure out the positions of the columns so that we can find the span, that's the length between the columns, the opening between the columns, and that gives us the length of the beam. So we need to divide this length by 10 so that we can have the required beam height. These are the principles that we need to follow all the time. And last time we talked about the floor structure. The floor is an element, and there can be different components that create a floor. And that middle part is one of its components. It's the floor structure, and we can cast it out of reinforced concrete. Just like we do for the columns and the beams. And there are different options. And all these options depend on the size, the shape, and the earthquake properties of the location. If we want, we can do flat slabs without beams. Uh, and there is this span limit. The maximum span can be 7 meters. The thickness of the slab can be minimum 10 centimeters, maximum 15 centimeters. However, because of the vertical loads, there is this punching risk. And since the earthquake casts lateral forces over the building structure, and since there are no beams to connect the columns to each other and support the floor thickness, then there is a high risk of collapsing down. Uh, in the earthquake-prone zones, we shouldn't prefer that type of floor. We need to go always for flat slabs with beams. Uh, we have the same limit for the span and the same thickness again for the floor slab, minimum 10, maximum 15 centimeters. And if we need a larger area, if you need to enlarge the floor area, then according to the shape of the floor, if it's rectangular, then we can have girders, smaller beams in one direction. And as you can see here, the shorter side can be up to 5 meters. However, we can enlarge the longer side up to 12 meters. That's what we call a one-way joist slab because the loads will be distributed towards the longer sides with the help of these girders, small beams. And if we are looking for a square-shaped floor, and if you want to enlarge the sizes span, of course, we can use girders in both directions. That's why we call it two-way slab, so that the loads will be distributed towards the four sides, the beams under the four sides, and we can have a span up to 16 meters this time. That's what we call a waffle slab. According to our previous decisions about the building mass, it's a geometrical form. And what we have found out during the analysis of the context about the ground properties and the bearing capacity and the earthquake risk and about the content, the user properties and the function of the building, we can make decisions about the floor according to sizes and the load things. So let's have this over an example. And please use one sheet of paper. It needs to be at least an A3 paper. And with me, you can do the drawing and experience it yourself. Just imagine yourself that you design a very tiny, small building. This is the final decision about the building mass. It has this rectangular shape. It's very simple, very plain, and there is this narrow road, and you have three steps, and there is this entrance terrace, an open air unit, so to say, and an entrance door, and we can use a plan in order to understand the indoor spaces. Here, you can see that there is only one volume with two different spaces, living areas. Here you provided a living area or sitting area for the user, and this can be used for small meetings or to eat something or to work, to study something, and that's it. That's a very small building with only one volume and three different living areas, one open air terrace area, and inside this volume, two different spaces. And of course, you can do a section so that people can understand, and you can do an elevation. And these are what we have decided during the schematic design stage. The building form, its geometrical shape, its visual aspects, the appearance, and the units, the spaces, living areas. And based on these decisions, we need to think about the structural system now. Uh, how we can create the structural system so that this form will be intact, and this form will not collapse down under different forces, the vertical forces, the horizontal lateral forces. We need to design a structural system to hold everything in place. And obviously, in order to create that geometrical form, that surface will be a floor, a horizontal floor. And it starts all this weight at this point. The floor itself has its own weight because of the gravity, and we need to figure out a way of transferring that load safely to the ground. And these are wall surfaces. If we make decision, if you decide that the structural system is going to be a masonry system, then all these walls will be carrying the loads of the floor and everything on it, all the layers, and they are going to be transferring them to the ground. However, if we change our decision and decide about creating a skeletal structural system, then the walls will not be carrying anything because there will be components, vertical components, in order to meet and carry and transfer the loads. And these walls can work only for the separation. Uh, for the separation of the indoor spaces from the outdoor spaces, and we can just think about them later and concentrate on the skeletal system. Uh, these will be columns, and they are going to be connected to each other with beams, and there will be a floor slab. And we can do all of these out of reinforced concrete. Uh, Here, let's note these down so we can use these dimensions during the drawing stage step. According to our previous decisions, the building mass, this size will be 4 meters, and that will be 6 meters. This is what we want to see as the geometrical form. This is what we have created. It's a rectangular prism, and the height will be 3 meters. There will be columns. Just remember, the minimum size. It's a very small building. There is no excessive loads, so we can have the minimum size. It will be probably enough. However, please do not forget, in real life, we need a structural engineer and they need to do the calculations. And that's how we can make the final decision about the sizes of the columns. And for the beams, again, we have this minimum size 25 to 30 centimeters. However, 30 is not enough. This is what we need to do. Here in this direction, there are two columns and the span is 4 meters. And in the other direction, there are other two columns and the span is 6 meters. So we need to take the larger span, that's 600 centimeters, and divide it by 10. Uh, we need to do this calculation. We have 600 centimeters and we need to divide it by 10. That's when we find 60. That will be the height of our building beams. The width will be 25 centimeters. The height for all these four beams will be 60 centimeters. So we can do that. And after that, we need to make decision about the slab thickness. As you understand easily, our slab size is smaller than 7 to 7 meters. The span, as you remember, slabs with beams, if we don't need girders, we need to keep it smaller than 7 meters in both directions. And this is what we do. 4 meters and 6 meters, they are both smaller than 7 meters, so we don't need any girders. The beams will be on these four sides, connecting the columns together and supporting the slab thickness. And the thickness of the slab, this middle part, will be 10 centimeters. The minimum size will be enough again for us. So these are our decisions. However, if you don't want to deal with 25 centimeters, then we can have 30 centimeters. It will be easier maybe for us to do the construction or do the drawing. Instead of this 25 to 30, we can just do a 30 to 30 columns. And again, 25 to 60 instead of that. We can have this 30 to 60 centimeters for the beams. But at this point, let's imagine that a square-shaped column. Okay, the earthquake creates this lateral load. It means that the columns will be pushed sideways when there's an earthquake, and it it square-shaped column. If you apply that lateral force, it's prone to fall down on this direction. If the earthquake hits from that direction, from that other direction, then again, it's prone to fall down. However, instead of a square-shaped column, instead of the 30 to 30 centimeter sized column, if you prefer a rectangular shape for the column itself, that means that instead of 30 to 30, we can just enlarge one of the sizes. We can create a 30 to 40 centimeters, enlarge it just slightly in order to have a rectangular shape. Then in this direction, the column will be weak, of course, but in the other direction, it will be very strong. It will be hard for it to tip it over. So instead of a square-shaped column, we can have a 30 to 40 centimeter column. We can just enlarge one of the sizes to create that rectangular shape, and we can position the columns like that. The first column can be like this. So it will be strong in this direction, weak in the other direction. However, we can change the position of the other column and create a rectangular shape in this other direction, like that. So this column will be strong in the other direction, in the direction that the first one is weak. And we can do the same with the other two columns. I can have this rectangle positioned like that. And for the fourth one, I can do the last. rectangle positioned like that. So my whole structure will be very strong in both directions. It will be harder to tip the column over, fall it down. Uh, so this is my final direct decision for the columns and their positions, and my final decision for the beams. They will be there's going to be a slab like this for 10 centimeter thickness, and the ends of the slab, all sides will have this beam, reinforced concrete beam like that, and it will be also rounded. And this thickness of the beam will be 30 centimeters, and this height of the beam will be 60 centimeters because of that 6 meter span. And this thickness for the floor slab will be 10 centimeters. So these are my final decisions. Now it's a more it's stronger building, a more stable building against earthquake loads. Now I need to make the drawing, start the expression phase. However, please pay attention. This is the decision for only the structural system. There are no walls, there are no windows, no doors, no furniture, no finishes, no installations whatsoever. Only reinforced concrete columns, four columns, four beams, and one floor slab. No foundation. Uh, if we haven't decided yet, then there's nothing for us to draw. So during the drawing phase, we are going to draw what we have decided. We are going to draw only four columns, four beams, and one floor slab without any walls, without any windows, without any furniture. Uh, Let's move on then to the expression. How can we express our decisions so that the structure can be constructed, can be built as we like, the expression of construction decisions? Here, we are going to use plan and section. And plan, it's a horizontal section. Just imagine you have a very large knife, you hold it horizontally parallel to the earth's surface, and it's elevated up to one person's eye level who is standing there. It's approximately 1 meter 70 centimeters, and you cut the structure as you see. Only four columns, four beams, and one floor slab. No foundation yet, no walls yet, no windows, no doors, and nothing else. Just reinforced concrete structure, no finishes, no insulation materials. So when we position our cutting plane horizontally at 1 meter 70 centimeters height and do the cutting, that means that we are going to elevate the upper part. We are uh, cutting the whole structure into two pieces. And as you can see, all four columns, they are being cut horizontally, and we just imagine ourselves, we are in between and looking down. And we need to do the drawing according to what we see. The first thing that we are going to see is the cut surfaces of these four columns. And in order to indicate that, we are going to use different line weights, and the thickest one, that thickest and black line, is going to be representing the cut surfaces. Here, there is a middle thickness line, and we are going to use that for the surfaces that we see, not cut, but seen surfaces. And there is one very tiny, very gray, almost barely visible line. Uh, these are the seen surfaces, obviously, and that very thin and very barely visible line is going to be our guidance. We are going to create guiding lines for us so that we can transfer certain sizes, certain information, and it will be easier for us to do the drawing. Uh, let's start with the cut surfaces. Okay, just imagine yourself, you are in between, you are looking down, and the first thing that you realize is all these cut surfaces of the columns. And we are going to use that very thick line. So if you have the opportunity, please do this with your hand, by your hand. Don't start with computer, the AutoCAD or any other program. Do it with your hand first, experience it, try to understand it, and then you can move on to softwares. Uh, and you can use one single A3 paper. That's our paper, let's say, this A3, and you can place it vertically like that. And first, you can create a title block, just what like we did during our courses, and you can put your information here. You can write the semester, the code of the course, and the name of the course. And here, this part can be divided into three pieces. You can write the homework number and the date, your name and surname, and your school number. And in this middle part, you can arrange your drawing so that it will fit and it will have this nice organization. So you can use this area to create your plan. Sorry, not like this, but this can be better, uh, probably. Okay, to create your plan here, this plan, and please leave certain gaps on four sides so that we can put some more information. We can write texts and other stuff on this left side and bottom part and the right side. And once you finish your plan, you can use this upper part in order to create a section uh, like that. And for the cut surfaces, you can use 2B pencils. And if you apply pressure, then you will get this very thick and black line. And for the scene surfaces, you can use HB pencil with a lesser pressure. And for the guidance lines, for you can prefer 2H pencil without applying any pressure at all, so that you can have very thin, barely visible and gray lines to transfer the necessary information from your plan to create the section like that. And if you prefer a normal squared paper, not a white paper, but a normal squared paper, something like this. No, the squared paper, there are squares, and these are already created guidelines for us. And not a millimetrical paper, but a normal square paper. Each one of these squares is approximately half centimeter, and you can have two of them for 1 centimeter, so that by using these grid lines, you can have a freehand drawing, a scale and freehand drawing. And if you prefer a white paper, then please use set squares and T-squares and do the measurement. Uh, because we are going to do a scale drawing and the scale will be 1 over 50. If you prefer square paper, then no need for ruler, no need for measurement. You can just count the squares. Two squares will be 1 centimeter, and you can have a freehand drawing, a scaled freehand drawing. Uh, okay, let's move on to scaling. The scale will be 1 over 50. That means that uh, we are here on the left side on the screen, you are going to see the real sizes of the building and the columns in centimeters or meters. However, on your paper, you are going to do a scale drawing, which means that you are going to create a 50 times smaller version of the real thing. That means that every 1 centimeter on your paper, a 1 centimeter line on your paper will be representing a 50 centimeter measurement size in the real world. So this is what we need to do. We need to calculate if I want to draw a 30 to 40 centimeter column, a rectangle on my paper in 1 over 50 scale, then I need to do this calculation. 30 centimeter in real world will be represented by how many centimeters or millimeters on my paper. This is what I need to think. Uh, do the calculation. That means that I need to multiply these two 30 and divide it by 50, and that gives us 0.6 centimeters. That means that one of the sides of my rectangle will have only 6 millimeters. So I can start with this point uh, and place my pen here on the paper. That means that if this is 30 centimeter, then I need to draw a 6 millimeter line with very thick and black line as a thick and black line to create that side of my rectangle. And I need to go 40 centimeters this time. That means 8 millimeters perpendicular to my first line and go this way like that for 8 millimeters and go that way like that for 8 millimeters. And that's here is the fourth and last line of my rectangle. So this is my first column. That's the column that I draw on my paper in 1/50 scale. I need to do the four columns like that. However, in order to find the location for my other column, here, first I need to uh, remember that total distance, and that's 400 centimeters. So I need to do the calculation. Again, I need to divide 400 centimeters into 50, and that will give me the scaled uh, version. To start from this corner, I need to find the outer corner of the other column, and I need to go uh, for uh, 8 centimeters this time to find this corner. That's the total size of the building. Here, I can place my other column this time. However, because of the positioning, I need to go 30 centimeters in this direction now. Let's do that together. Starting from this point, I need to go 30 centimeters in this direction and 40 centimeters in the upper direction to create a column like this. So that's my second column. Because of the mouse, I cannot draw it regularly on the screen. They need to be the same. And once I do that, I need to move on to my third column. And that means that I need this distance, total distance, and that's 600 centimeter uh, in real world, which means that I need to divide it by 50 and find the scaled distance. Here, go that way for that millimeter or centimeter and create my third column here. I can start with this outer corner, that corner, and this time I need to go 30 centimeters in this direction and 40 centimeters in that direction with thick lines. I can create my third column. And for my last column, I don't need to do any more measurement. I can just have a guiding line towards this distance with a very thin and gray line and another one from this distance. And the corner here will be this outer corner of this fourth column. I need to go 8 millimeter downwards for 40 centimeters and 6 millimeters towards the left side for 30 centimeters and complete my rectangle like that. So let's have a look now. This is what we do. We start here again from this corner, that's this corner, and first create that column for 30 to 40 centimeters with thick lines because they are cut surfaces. And then I need to go for 4 meters in this direction, which gives me this outer corner of the second column, that one. And according to the position that I see on the left side, I need to create one more rectangle positioned like that. And then starting from this point, I need to go this time 6 meters upwards. That will give me the third outer corner here. That's the one. And position my column like that. And for the last corner, that's this outer corner of this column, I need to go 4 meters one more time in this direction towards the right side and position my fourth and last column with thick lines. So you can do it with me. If you want, you can pause the video and continue once you finish because now let's check. Is there anything left behind which are cut that we need to add as a drawing? As you can see on the left side, there are no else cut surfaces. We draw 4 columns and that's it. So we need to move on to the scene surfaces. As you can easily understand, the upper surface of this floor and upper surface of these steps and the road, the edges I'm seeing, they are not cut with any horizontal planes, but they are seen. And in order to indicate that, I need to use this middle thickness line, and I can just connect the sides of these columns to in order to indicate that side of the floor and this side of the floor and that one here. And there is a difference between these two because this is a terrace area and this will be the indoor floor surface. We can have one line to separate them from each other. And for the terrace, the size of this side is 1 meter. That is 100 centimeter. Again, in real world, I need to do the scaling, which uh, I need to divide it by 50 and find 2 centimeters for my drawing. And as you can see here, the terrace is with the same size of the 6 meters, this here. However, I need to go for 300 meters towards this direction in order to find this corner of the first step. And I can have 1 meter for the steps, which means that I'm going to do 2 centimeter upwards. And the rest will be just terrace area. And each one of these steps, they have 30 centimeter uh, thread surfaces. So I need to do a 30 centimeter towards this direction, a 30 centimeter scaled 30 centimeter towards this direction, and that will be all. If I add them, then that means that I finish all the scene surfaces. I'm checking from the perspective, there is nothing else that I see, only the earth, the upper surface of the earth, and I don't need to draw anything in order to indicate that. And as you can see, the road, it's open. Uh, there are only these two lines in order to indicate the edges of the road, and that means that it is continuing towards this direction. It's a continuous road. I just draw a portion of it and it continues towards this direction. If it's open, it gives that understanding. And here, I draw everything I see, and there is only one more thing that I need to add to my drawing. It's the edges of the beams. I cannot see them because I'm looking downwards and they are above my head. However, I need to indicate them on my drawing. So with this middle thickness lines, I am creating dashed lines, the same thickness, same blackness, but not a continuous line. This time, just a line and a gap, a line and a gap, equal lines and equal gaps. And with this same thickness, I can create the sides of my beams. I cannot see them, but I'm indicating them as the projection. And please don't forget the width of the beams is 30 centimeters, same with our columns here. So I can start with from this point and go towards, and this thickness will be the thickness of the beam, that one. right? That's my reinforced concrete beam. And this is 30 centimeters. This is what I'm indicating. This side, its projection will be indicated like this here. And another line in order to indicate that beam on this side, another one for this beam, and the last one for that beam. Four beams will be indicated with these uh, dashed lines. And nothing else to be drawn. Everything will be represented. Now we can move on to section. Uh, that means that we are going to do one more cutting, but this time our plane, our knife will be vertical. And it will cut through the middle part of the steps. So I'm cutting the whole structure vertically this time. And uh, when I do the plan, when I cut the structure horizontally, the columns were the cut components. However, now columns, they are not cut. And uh, the other things, the floor slab, the beams on each sides, and the ground floor, and the steps and the roads, these will be the cut surfaces. And I'm going to look towards this direction up here, and there will be certain things that I'm going to see. So first, let's start with the cut surface, indicating this cutting vertical plane uh, here on our drawing. And in order to do that, we are going to use a section line. Uh, and we are going to do it with this very thick and black lines that we created the columns. The same thickness, but a different shape. Here, this time, we are going to do a straight line, a small gap, a point, another gap, another straight line. And these straight lines needs to be equal to each other and gaps as well. And it goes like that. So we can create that thick line in this shape to indicate that we are providing the section in this direction. That means that we are separating this, dividing the whole structure into two pieces. Now we are in the middle part and we are looking towards that direction. And let's add that section line with these two small triangles for the looking direction. And with these very thin and very gray lines, first let's create a guidance for ourselves, and then let's start drawing the section with these cut surfaces. As you can see here, the whole earth is being cut, and this 45 centimeter height of the ground floor, it's being cut, and these steps, they are being cut, and the road is being cut. And as you can see here, the beam on the left side, the floor slab with 10 centimeter thickness, and the beam on this right side, they are being cut. So we can have these very thin and gray lines. We don't need to erase them. We can just leave them as they are. And we can use that to transfer this size of the beams. It can start from here. I just create these red lines so that you can understand it better, but you don't need that color on your paper, obviously. You can use only one pencil and create these gray and thin lines. And it starts from here because that's where the beam is being cut. And I can just go upwards like that, and then the inside edge of the beam go upwards like that, and this will be the floor slab. One more beam on this side here, and then the end of the terrace, and each one of these steps, it will be transferred like that. And with again very thick lines, the same thickness that I created the columns and the section line, I can start by drawing the earth, the upper surface of the earth, and then I can go 25 centimeters upwards. That's the measurement for this height. It's 25 centimeters here. I can go upwards and I can create a straight line in order to create the floor surface, ground floor surface, and the terrace area Right at that point, I need to go downwards for 15 centimeters because that's the height of each riser of the steps. I go 15 centimeters downwards, of course, scaled version. And then while using that guideline, I do a straight line in order to indicate the cut surface of the step, the thread, the upper part, and then go one more 15 centimeters downwards, and then do the last step and do the roll. And that's again with open ends means this line is continuing towards this direction. It's a continuous line. It indicates the upper surface of the road and the earth. And I need to go 3 meters upwards from starting from this point and go upwards for 3 meters. Uh, First, I need to do the calculation and find the how many centimeters that I'm going to draw and find that upper corner of the beam. And that's it, this corner here. That means that I need to go 60 centimeters downwards. That's our height for the beam, 60 centimeters. This height is 60 centimeters. And I have the thickness here. I can go 30 centimeters. I don't need to measure it one more time because it's already there. And go 50 centimeters upwards because of the slab thickness. There is this 10 centimeter thickness. So if this is 60 and if this is 10, then I need to go 50 upwards in real sizes and create this uh, floor slab with two beams. Do the same for this beam here, and that's it. These are all the cut surfaces of the building structure. Now I can move on to the scene surfaces. When I stand here, I just imagine myself, I'm standing here and looking towards this direction. I'm seeing the inner surface of this column, this red one, the inner surface of this beam that is uh, parallel to my position and the inner surface of this column here. So we can do one more guiding line, send the width of this column. Here it starts from here and go upwards, and the other one starts from here, go upwards, the inside surface of this scene surface of the column, and do the same for the other column here, go upwards like that. And we have the beam here. So with the middle thickness lines, because they are scene surfaces, we can create the inner surface of the column and the beam and the column. And that's it. That's what we are looking at. We draw all the cut surfaces and the scene surfaces, and that's all completed. The drawing is finished. Now we need to do some explanations. We need to add certain explanations. The first thing is to emphasize the cut surfaces of the plan and the section. And here, as you can see, I'm using thin lines, but one 45-degree inclined line, a continuous one, a little gap, and then I do a dashed line in the same uh, shape, in the same direction, and one more continuous line, and then one more dashed line, and it goes like that. I'm filling all these cut surfaces of the columns here with these lines. This is what we call a hatch. And this hatch indicates that these columns will be created out of reinforced concrete. This hatch specifically indicates the reinforced concrete material. And I need to do the same for the section as well because all these cut surfaces of the beam and the floor slab and the other beam, they are going to be reinforced concrete. So I need to fill the whole gap with this same hatch. And I can add these inclined lines, but this time only just inclined lines like this. Thin lines, as you can see, to indicate the earth that's being cut. Uh, to emphasize the cut surfaces. And that's it. Now the drawing is complete. Now I need to add some more explanations, starting with the grid lines. This is what we call a grid line. As you can see here, it's the same with the section line. However, the line, gap, point, gap, line, gap, point. However, with this middle thickness here, I can do these lines and I can start from the middle point of this column and middle point of this size here. So it's 15 centimeters, 15 centimeters, because this is 30. Again, the middle point here and the middle point of this column here, like that. And I need to do one grid line to indicate these two columns, and it's go like this, it goes like this, only with thin lines, not thick lines. If it's thick, then it's a section line. If it's thin, then it's a grid line. I place one grid line here and one grid line here in this direction and one grid line here and the last one here. And I'm going to give names for these grid lines uh, for the shorter side. Obviously, we have only four columns, two columns on one direction, two columns on the other direction. But just imagine yourself. Uh, let's s- let's let's think that we created a building like this, and there is lots of grid lines in this direction, and lesser grid lines in this direction. So, with the large number, you use numbers. With the short side, you can use letters. Because there are only 29 letters, but lots of numbers. That's why. So I just have A for this first grid line and B for the other grid line and 1 for this first in this direction and 2 in the other direction. But as you can see, if you like, you can have a continuous line go all the way down. Well, I don't do that because there will be some other explanations and I don't want a confusion. So I just leave the middle part empty and continue in the outer surface, and that will be that will help us to communicate about these columns with the structural engineer and the builders and everyone. When I say B1 column, that means I'm talking about this one because that's B and that's one, and the intersection it's this column. When I say A2 column, it's the intersection of these two grid lines. So I'm talking about that column. With these lines, grid lines, it will be easier for me to name the columns, and once we do the grid lines, we can move on to the dimensions. I need to give dimensions for the columns and for the floor and for the beams so that builders can build that as I like, as I have decided. So I create new line like this, okay? So this is a dimension line. It's basically one single line like that. And if there's already a line here, I don't need that arrow. Let's say that's an arrow, but if there is no line, I need that. So I create that one and I create one more line. And these are like the arms. They are pointing towards the column. So they are giving me this size of the column. And I need to do that 45-degree angle in order to emphasize the size. And I will put my number here, 30. It's in centimeters, but I don't do S and M at the end. Okay, just the 30 will be enough. Uh, and that's the size of this column here. Uh, I need to give the sizes of all columns, not only in this direction, but in the other direction as well. And I need to give the gaps between the columns. So I continue this line, and this is 50 centimeters, as you can see. And in between, there is 320 centimeter gap. And these are the real measurements, not the scaled numbers, but the real numbers. So I gave the size for this column, the gap, and the other column. Uh, as you can easily understand, it's with this indication, I'm giving the total 50 centimeter of the column, not the beam. The projected things with this dashed lines, we don't give any dimensions for the projection. Okay, we just give the dimensions of the real things. And I can do the same with these columns, start with the 50 centimeter and leave the gap, give the gap in between and 30 centimeter here. And I need to do in the other direction for the columns, start with 30, and this time it's 520 centimeters and 50 centimeters and 30, 520, and 50. So all the columns can be created because I have the sizes of all four columns and their gaps. So if the builders start from this column, but with this column, they're just going to create a 50 to 30 centimeter column. Here, and then they are going to leave a 320 centimeter gap in between and create another column. By the way, this is wrong. Obviously, you realize that we have decided that we are going to do a 30 to 40 centimeter. However, in the drawing, there has been a mistake. It needs to be not 50, but 40, obviously. It's a mistake. Uh, and builders can build all these four columns. Uh, and we need the total sizes. Starting from this outer corner, I need to give the dimension of the total size. That's 400 centimeter, and do the same with the other direction. And for the last dimension group, I need to indicate the grid spans or the spans between the grid lines, the distance between the grid lines. I just need this dimension line with these inclined ones, and it's 370. And in this direction, the size between the gap between the 1 and 3, 2 grid lines, it's 570 centimeters. So the plan is completed now. With all these dimensions, the builders can build the structure, these four columns uh, like that. I need to do the dimensions for the sections, but only vertical ones. In the section, we don't have horizontal dimensions, only the vertical dimensions. And I can start with the upper surface of the Earth and indicate that this will be 45 centimeters, the height. And then the height of the column, it's going to be 240 centimeters. The height of the beam, it's total 60 centimeters, but with the 10 centimeter floor thickness, there will be 50 centimeter left. So I can indicate it like this, and that's it. That's the all dimension that I need. Uh, since the dimensions are completed, I need to put the level marks. Here, as you can see, this is for the plat, and those are for the section. You can imagine it like this object that you see on the screen for the plan. Just imagine yourself, you are looking from the above, you are doing the top view, and you are just creating one circle with a plus sign, but the side is larger, longer, and it's all black here. And for the section or the elevation, you are on the side of this object and looking sideways. It's the elevation of this thing. So we have a triangle and a straight line so that we can put the numbers on it. And again, it needs to be in black shape. That means that that's the level of unfinished surface, reinforced concrete surface, and there will be finishes over that, but not yet. Obviously, we don't have these decisions. And we are going to put the levels in meters this time. As you can see, I start with plus and minus 0.00 because that's the upper level of my ground floor. That's our zero level. And I need to put the same here on the section. And I need to calculate the upper level of this reinforced concrete floor slab, and that's 300 centimeters upper than the ground floor. That means a plus 3.003 meters here. And I can use the same sign with this arrow towards this beam and give the lower side, lower surface of the beam. And it will be plus 2.40 above the 0, 0 level. And this here, the level of the road or the earth, will be minus 0.45. It's 45 centimeters lower than the zero level. And do the same on this other side. As you can see, they are symmetrical because uh, it's like an arrow towards the lower side of the beam. And that's it. Uh, and the last thing will be is putting the material and product information. I need to write with this little arrow. This is a reinforced concrete column, a reinforced concrete column. That's a floor slab. That's a beam. This is a beam. And on the plan again, reinforced concrete column. And that's it. That's how we create a 1/50 scaled technical drawing of this constructional drawing of this structure. So when you give that to builders and engineers, they can be able to create the the structure as you like. And please don't forget, there are no walls, no windows, no finishes, no insulations, just reinforced concrete, four columns, four beams, and one floor slab. And this is what we draw here. Okay, we learned about the expression of the construction decisions. Last thing, is the structure stable enough? Let's check that. In order to find out, this is what we can do. Here, if I draw this cross sign on my plan, that will give me the central point. That's the geometrical center of the building. And I need to think about the loads, the weight of these beams and columns and the floor slab. And if the center of the gravity, the center of the loads is at the same point with the central geometrical center, then it's good. When the earthquake happens, these lateral forces will uh, not cause any damage here because they overlap. This is something that we want. However, just imagine instead of this singular column, you prefer a shear wall, and that makes that corner of the building heavier than the other three corners because you created a very large column, a shear wall, and it's a very heavy object. That means that the central point for geometric center, it stays put. However, the gravitational center is not at the same point anymore. It moves towards the heavier object. That means that this side of the structure is heavier. And when the earthquake happens, when the lateral forces are applied, that means that that side it doesn't want to move. And these three columns, since they are lighter, they want to move. And that will cause this part to rotate. And this will stay put. It doesn't want to move. And these parts, they want to move. So the whole structure starts to rotate. And that's very dangerous for us because the connections of the beams with this shear wall can break. Because of that rotation and because of that force. And that's something we need to avoid. Uh, that means that either we can try to find possible solutions to put the gravitational center back on the geometrical center one more time. And in order to do that, we can just give up the shear wall and use a column, or we can enlarge the other columns so that the gravitational center will be overlapping with the geometrical center one more time. Uh, the same with the stories. Let's imagine instead of this small building, we have this two-story part now. And in normal conditions, this is what we need to do. If we we need to measure this size here, and if it's more than 7 meters, it's more than 7 meters. It's not smaller, shorter than 7 meters. Then it means that if we place a column here, another one here on this corner, and one here and one at the back, and if the gap is more than 7 meters, then it needs columns, obviously, uh, here, like that. These columns, and it will go upstairs as well. That's what we do. We connect them with beams and we go upstairs. We place the floor slab here and do one more floor like that. That's what we prefer in normal conditions. However, because this has 2 stories, this side of the building is heavier than the other side. And during the earthquake, when the lateral forces are applied, that heavier side, it doesn't want to move. However, this lighter side, one-story side, it wants to move, and that will cause damage here in these connections of the beams and the columns. Because the gravitational center and the geometrical center, they don't overlap. We need that. Here is an example. Okay, there's a problem with the video. I can show it later. Doesn't matter. Uh, in order to avoid that problem, we can divide the whole structure into two neighbor buildings. Not just one single structure, but two neighbor structures. And there is no connection at all here. And instead of just one set of columns, we can create two sets. That means that not one just single structure, but two neighbor buildings with 4 columns for the first building, and we just leave a very tiny gap and create a new building, a neighbor building next to it with its 4 columns. So there is no connection at all. There is this tiny gap all the way down, and this first building can go upwards. So instead of just one building with the unstable load distribution, we can have two neighbor buildings with a gap in between. That means that in order to do that, and obviously the grid lines, it changes. Here, the first one is A. The middle one is B, and now it's B here and B apostrophe, as you can see here, a new grid line, and it's C. Uh, During the construction, first we construct this part of the structure, that building, and we complete the construction. And in order to create the neighbor building next to it, we can use these XPS boards. You remember them from our last course. We can cover the reinforced concrete surfaces with these boards and create new molds and cast the new columns and new beams, and those will stay put. So that tiny gap will be created with these XPS boards, and we can indicate them with this hatch, this spatial hatch on our plan, because when we do the plan, uh, those XPS boards between 2 columns will be cut, and the thickness will be only 5 centimeters. That's it. So thanks for listening. I hope all these information, all these examples will be useful for you. Please do your homework, as I explained throughout the video, and you can submit it on LMS and in the classroom on next week on our course. Okay, see you.